Hello, my name is Krystian. Welcome to my course on change. We're starting with the first lesson. The first lesson will be dedicated to an introduction to matrices, a certain introduction to the concept of matrices, what is a matrix at all, and a few basic matrix operations like addition, subtraction, and matrix multiplication. When it comes to matrices, well, they appeared along with such a need to the needs of solving systems of equations where there are many unknowns. Many meaning more than 2 and more than 3 unknowns. So we have a lot of parameters and we have a lot of equations with such systems where there were 2 to 3 unknowns. I guess you managed in high school and at some point in the development of science. And humanity has reached a point where it is no longer sufficient. We had to solve increasingly complex systems with an increasing number of unknowns. And at this moment, I was cutting matrices. And here's the answer to a basic question I often hear from my students. Namely, what will I use this for? What am I going to get out of this? Why is this going to be useful in my life? Some people say, why is this going to be useful in my life, these whole matrices? So if in your professional life, if at university, wherever you encounter such problems, questions, where you will have many unknowns and many connections between them, sometimes you will know, well, at this point, matrices will be useful to you. Although the unknowns in the systems of equations is a very broad concept, they can be both some parameters in physics, as well as resources in economics. Notion need to be minimized to obtain minimal costs. For example, in optimization tasks, these can be some properties in chemistry, even in biology. If you will have several unknowns and they will be related to each other in many ways, and you will somehow have to solve it. This is when matrices will come in handy for you. And one can learn about matrices for just that one reason. All right, let's get started. One must have some skills before starting to learn about matrices. Well, the good news is that not much, actually just what is written here. Add, subtract, multiply, divide, positive and negative numbers. This is knowledge from the very basic range. In general, the good news about matrices is that it's a simple operation. All the schemes, the algorithms you need to learn here is because these matrix solving patterns are not hard to understand, not very complicated. What's the deal with this addition, subtraction? What kind of specific operations could these be? Well, for example, yes, you should easily solve subtractions like 3, 7, or 4, 8, positive numbers through minus 3x4. Well, and such, so some slightly more complex things that we have multiplication and addition, right? Minus 4 times minus 3 plus 12. Knowing this means you can't immediately answer the questions. So, for example, what is minus 4 times more? Roughly add 12, that it is 24, because it is. But the point is that you should simply not find this difficult. You should not make mistakes on this. Didn't make many mistakes. If you're not sure what minus 4, minus 8 is, or you're guessing, well, it would be appropriate before starting with the matrix to go somewhere to a bookstore, buy a primary school book. Of course, not being ashamed. Just calmly remember the rules there. Why, for example, minus 4 minus 8 is minus 12. What is a matrix? We start from this. What is a matrix at all? We explain such a simple definition. No joke, not too strict mathematical, that a matrix is a table written with numbers. It would be good to add a rectangular table. As you can see here, we have this array. There are different numbers. It is worth noting that these numbers in the matrix, we say that these numbers are elements of the matrix. So the elements of the matrix cannot be rounded the whole number, right? 1, 2, minus 7. There may be fractions, just like here. There can also be irrational numbers, like here. That square root of w is an irrational number. Generally, in these matrices we will solve, there will be nice whole numbers, but there is no rule. let's go ahead and introduce some basic different concepts related to matrices. Numbers written in these horizontal lines, like here, these are rows. This is a row. You could say it's the second row. Counting from the top, this is the second row. These are numbers written in fluid lines. These are columns. For example, this is the second column. We count from the left, second column. The second column is 2, 2, 5, and 4. You can calculate that this matrix has 4 horizontal rows and 5 vertical columns. 4 rows and 5 more, so it is of dimension 4 or 4 then, that there the matrix has a dimension of 4 to 5. Note that in the matrix dimension, the number of rows goes first. And then the number of columns, let's emphasize it again. This is the dimension. There is no requirement to indicate the dimension in every matrix, but you need to know what the matrix dimension is, because I will often use this word. Not so sen enough. Now let's move on to these basic operations on matrices. Still quite simple. It will be addition and subtraction of matrices. Of course, matrix multiplication by a number, multiplication by matrices, and matrix transpositions. Let's discuss them one by one. We start with matrix addition and subtraction. Matrix addition and subtraction is a very simple operation. What needs to be done? You need to add corresponding elements of the matrix and write the result of this addition in the resulting matrix. Add the first element of the first row of this to the first element of the first row of this. I will write it down on the side. What will it be? 3 add minus 2. 3 minus 2, that is 1. I write the result in the first row of the first column. So the first row, first column, such element add to the first row, first column, such element, and the result is written in the first row of the first column of the resulting matrix. And so for the first row, second column of the matrix on the left, add the first row, second column of the matrix on the right. I'm writing this on the side, minus 1 at 4. Minus 1 at 4 is 3. I'm writing the result here, 3. Next, add the first row, cut the column of this one, and the result will be recorded immediately. If you can do this in your memory, that's great. 4 plus 5 minus 1 plus 4. If you can do this in your memory, do it right away. That's good. But if you often get this wrong, then feel free to write on the side, just like I did in these 2 first actions, and so on. Next, we add all the corresponding elements. Yes, so 12 plus minus 3, plus and minus gives minus, so it is 9. And for the minus 2 plus 4 is 2, 3, add 2, and it's 5. Continue factor 4. If you add 0, the result here will be 4. 2 add 1. Ce reicht 0 plus 1. Asta 1. Next, minus 1. At 1, the result will be 0, right? Minus 3. At minus 3, pay attention. At 3, it will be 3. 3. So on 6, I will write the result here. No? And for the minus 4 plus 3 will be minus 1, right? And I'm writing down here minus 1. Very simple, right? It adds the corresponding element to itself. Assuming someone is already fluent here, I've already talked about this. Fluently adds positive numbers in general. Subtraction happens in a similar manner. One needs to be a bit alert with subtraction as the signs tend to change a bit. This might be a bit tricky. Here slowly, so cautious, and I'll be detailing. Minus 3, I'll insert the result here. And here this is written out. 2, 3, this is a note. 2, 3, which means this is 1. So here I'm writing down 1. 3, 5. I'll write the result down here. 3 minus 5 is minus 2. I write here minus 2. Next, 4 minus minus 1. The result will be written here. 4 minus 1. 4 plus 1 is 5. If you're doing this in your head without a problem, you can write it down here boldly. You don't need to write it on the side. 2 minus 2 is 2 plus 2. So the result is 4. I enter 4 here. This is 1, 3, 1, 3. The result is 4. I'm entering 4 here. The score is 10-2. I am writing down 5. Here I am. Minus 4. 5 minus 4. The result is 1. I'm entering the result here. 1. 0 minus 2. Spelled out here. It is 0 plus 2. So the result will be 2. I enter here. 2 minus 2 written out here, it will be 0. You just need to be vigilant here with this minus. Now let's imagine that we have to add 2 such matrices. This is such a problem. Well, if this addition were to look something like this, we would add it, and there's no problem. Aishi so far to this, to do this, right? To do this. And it's unclear what to do with this row, right? There are no elements corresponding to this. Addition, as I said, is the addition of corresponding elements, but nothing and none corresponds from this matrix. The conclusion from this is that the task is impossible. Not every 2 matrices can be added, and not everyone can be subtracted. There are no corresponding elements, so we won't add or subtract. The general rule is that matrices can be added or subtracted if they have the same dimension. Well, because then all elements have their counterparts. This rule applies to both addition and subtraction. If they don't have the same dimension, such a task may occur. Such a trick, one could say, well then it should be like, handle it like I did here, which equals an impossible action, and that's the end of the task. We don't mess with zeros, or something like that. Another very simple operation on matrices is multiplication of a matrix by a number. Note, a matrix by a number, matrix by matrix will be in a moment. Even by the numbers, we have a number here. This is number 4. And if we want to multiply it by this matrix, we multiply each element of the matrix by this number, and we write down the results here. So each element, we just multiply by this number. It's very simple. We start 4 times minus 2. 8. Let's write it down. 4x minus 2 is minus 8. We will write this minus 8 here, and so on. 4 times minus 1. The result will be here. Writing down 4 times minus 8. I'm sorry, this is minus 4, so we write here minus 4. The 4 times 0 is 0. 4 times 1 is 4. Now 4 plus 2, right? 4 plus 2 is 8, and 4 plus 2 at the end is also 8. A very simple operation, right? You can say that, as it is written here, multiplication of matrices by a number is always executable. Cases, if it's about each element being multipliable by a number, it's enough to have some elements. So multiplying a matrix by a number is always done. The most difficult type of operation from these. The hardest of these basic operations is matrix multiplication by matrices. It's not like this, not that simple that we will multiply corresponding elements by themselves. No, multiplying a matrix by a matrix is more complicated. No, I recommend doing it to this auxiliary table here, you could say, somewhere on the side for yourself, underneath, or on the margin. Well, on the margin, if it fits, we perform such a thing. And now this matrix from the left side we put here into this part of the table. This is on your right. We put it here into this part of the table. It matters which one is on the left, which one is on the right. We'll talk about this in a moment. And we have it this way. We'll write the result here. Now like this, we multiply all the rows of the left by all the columns of the right. So we start with the first row and multiply by the first column. And we will record the result here at the intersection. of this verse and these colors. How do you multiply a row by columns? Multiply corresponding elements by themselves, and I add the results together. So we start -2 times -2 is 4. I will be writing down the results of these multiplications on the side. So -3 times 3 is -9. I write down here -9. 1 times 2, that is 2. I write down here +2. At the end, I add these numbers. 4 minus 9 is -5. Add 2, that is -3. And I write these 3 here. At the intersection of this row and this column, I'm multiplying this row again, this time by this column, and I'll write the result here. Well, this will work. I multiply the corresponding elements. -2 times -1 will give me +2. -3 times 0 gives me 0. And next, 1x2 gives me 2. 12 plus 0 plus 2 is 4. I write the result here, and in this way, the truth is created material. And moving on, I multiply this row by this column. -2 times 2 equals -4. And moving on, -3 times 1 will be -3. And times -1 will be -1. So I have 4, 3, 1, that's minus in total. I write the result here in -8. I've run out of columns here. So I move on to the second row and multiply it again by this column. And I'll write the result here. -1 times -2 is +2. 4 times 3 is +12. 0 times 2 is +0. 2 plus 12 plus 0 equals 14. I write down the result 14 here, and so on. This row times this column, -1 times. -1 is 1, 4 times 0 is 0, 0 times 2 is 0, 1 plus 0 equals 1. I am writing down the result over here and there. And further, this row times this column will be -1 times 2, which is -2, plus 4 plus 0, -2 plus 4 plus 0, that equals 2. I write down the result here, 2. What I was calculating here was just calculated on the side. I have to go back here now and write down the result nicely, as if on a clean sheet. And that's the end of the task. This matrix multiplied by that one gives this matrix. We can also multiply such strange matrices. Well, strange. One row, right? And here we have 4 columns. We multiply. Then left, then right. This row I multiply by this column. I wrote the result here. And here is a description of this result. 1 times 2 gave me 2 negative. 2 times 2 gave me -4. 3 times 0 is 0. -1 times 4 is -4. And 2 minus 4 add. 0 minus 4 gave me -3. And here I wrote a -6. And moving on, here I multiplied this row by that column. -1 times -1 gave me -1. -2 times 3 gave me -6. 3 times -1 gave me -3. And -1 times 10 gave me hello, and -10. And here I have all these numbers written down. -1, -6, -3, -10 is minus. So the result here will be -20. So I got this matrix. This is the result now. 1 row, 2 columns. You'll get what here. This is also a table, just a number recorded against it. Let's now take 2 matrices multiplied by each other. This truth to the left, that one to the right. And if I wanted to multiply them, I would now this row, he multiplied it by this column, and I would like to record the result here. But let's notice what this multiplication would look like. This times this I would multiply, then this times this times this, and there's a problem. Here there is no 3 to multiply, right? There's no 4th element of this column here. This row has 4 elements, this column has 3 elements. I don't have these 3's to multiply, kind of the same problem as in addition, and exactly the same. We interpret this in a similar way. This is an impossible operation. Not every 2 matrices can be submerged through each other, and we see that this is more complicated than this condition. It won't be that simple. there have to be different exchanges. The condition is that two matrices can only be multiplied if the number of columns of the left matrix equals the number of the first matrix on the right. The number of columns on the left equals the number of rows on the right. You can always put matrices into these tables. Look at this table and you'll see the problem with this multiplication. But before you multiply, you should check if this operation can be performed at all, because it will save you time if it's not performed. Let's look at these matrices. That's how it is. The number of columns in the matrix on the left, that is this one. How many columns does it have? Columns are vertical, 1, 2, 3. It must equal the number of rows of the matrix on the right. See some more shape. This is from the right. How many rows does it have? 1, 2, 3. The left column is 3. There are 3 rows on the right. The operation is done. You can multiply these two matrices, and let's take a look here. The number of columns in the matrix on the left now here is 1, 2. The number of rows in the matrix on the right is 1, 2, 3. So the number of columns in the matrix on the left is 2. The number of rows in the matrix on the right is 3. This operation is not performed. These two matrices can be multiplied. Well, let's see then. The conclusion from this is that matrix multiplication is not commutative. What does that mean? This means that in general, again, A times B is something different. If A is a matrix, B is a matrix, so matrix A times matrix B. So this is different from matrix B times matrix A. It matters which matrix is on the left and which is on the right, which will have more consequences later. So what's the difference between matrix multiplication and number multiplication? In numbers, it didn't matter if it was 2 4 or 4s2, but in matrices, it's not the same. In other words, multiplications, this times that does not give us the same as that times this. The last basic elementary matrix operation is used for something else. This is matrix transposition. It involves swapping the rows and columns of the matrix. We denote them with such a letter T. Just so you know, this means transposing. The first row in this matrix is 1, 2, 0. So the first column of this already transposed matrix will be exactly 1, 2, 2.0. I'm writing this first row in the place of the first column, and so on the second row will be 3.3, 1.2. So here the second column will be 3.3, 1.2, the third row, 4.4, 1.3. So here the third column will be 4.4, 1.3, the fourth row 2, minus 1, minus 2, 3. Is the fourth column 2, minus 1, minus 2, 3. Very simple. You can also transpose non-square matrices, of course. You can transpose any matrices at all. The first row here, 2, 3, 1, 1. So the first column, 2, 3, 1, 1. The second row, 4.1, 2.1, or the second column, 4.1.2.1. You have to sponging, as I said, you can with any matrix. As for matrix exponentiation, it is not a separate operation on a matrix, something independent. Matrix exponentiation is just simply, matrix multiplication is actually, well, because the squared is calculated as a times a. Not that we square the elements of this matrix A, but we multiply this matrix by itself. And to the third power is A times A times A. Very straightforward. For example, square this matrix. If you square it, you get this matrix times that matrix. We already know how to multiply. I'm writing it out here in this scheme. Minus 2 times minus 2 is 4. 3 times 1 is 3. The result is 7. I write down the result 7 here. Minus 2 times 3 is minus 6. 3 times 0 is 0. So minus 6 plus 0 is minus 6. 1 times 2, 2, add 0, that's 2. I write the result 2 here. 1 times 3, that's 3. Add 0, it's 3. Add 0, it's 3. I write the result here 3. And the result of this operation is entered at 307. Minus 6, minus 2, 3. This is how you exponentiate matrices. It's not some separate operation. If we can do all these basic matrix operations, we can use them all at once, like here, such compounds. It works. We remember the order of operations. Maybe it's worth adding that transposing has to be done at the beginning. Yes, multiplication takes precedence over subtraction. And it's easy to remember, right? In parentheses, right? Let's finish this first. If you remember this order of basic operations from elementary school, you can feel free to solve more complex problems. Here, for example, we need to transpose this matrix at the beginning. This is that small part transposed. The first row was -2, -1. The first column was -2, -1. The second row was 0, 2. The second column was 0, 0. Which operation should be performed now? Here it is. We need to perform these multiplications. No, we don't do that here with this thing, this scheme on the side. 4 times 2, 8 3 times 1 3, 8 3 lever. 4x0 is 0, plus 3x2 is 6, 0 plus 6 is 6. Minus 1 times minus 2 is 2, minus 2 is 0. And show plus equals. So multiplying these two matrices by each other gave this matrix as a result. So I'm entering this matrix as the result of multiplying these two. Now the operation in the bracket has to be performed. Here it's subtraction. We will perform here, maybe I'll go over this slowly. Minus 11 minus 3 is minus 14. 6 minus minus 1 is plus 7. 0, 2 is 2. First 1 is 3. And here is the matrix that is the result of subtracting this one and this one. Now we need to transpose this matrix here. Here is transposed as negative 14.7, first row. The first column was negative 14.7, negative 2.3. And finally, do the dimming, subtract it. And their matrix, this is the result matrix. It means this is just the result. Minus 14, minus 2 is minus 16. Minus 2 minus minus 2 is minus 16, which means 0, 7, minus 1, 6, 3, minus 3. This is the answer. Let's do such an operation. At the beginning, of course, you need to multiply these two matrices together. We make a helper diagram for this. We insert these matrices in the appropriate places. And we multiply this row by this column. Here it's broken down. Minus 1 times 2 equals negative 2. 3 times 0 is 0. 7 times 1 is 7. The result will be here 5. This row through this column, minus 1 times minus 4. 4. 3 times 3, 9. 7 times 2, 14. 4. Add 9. Add 14. 27. I write the result here. 27. 2 times 2 is 4. Add 0 is 4. Add 0 is 4 to 8. The result is h. The x minus 4x minus h. 3 is 3x3, 9. 4x2, 8, 8, 9. Add 8. That is minus 9. I enter here the result, minus 9. This is the result of multiplying these two matrices. We still need to transpose it here, right? Here is the transpose result. I swapped the rows and columns, right? And that's the answer. Let's now perform such operations. Here we will have to first transpose this matrix because we cannot subtract these two straight away. I transpose first row for 1, first row for 1, then 2 to 5. Here I write 2 to 5. Now I subtract these two matrices. 4 minus 3 is 1, 2 minus negative 3 is, be careful, 5, 2 minus negative 3, which is 2 plus 3. 1 plus 1 is 0. 5 minus minus 2 is 5 plus 2, which is 7. So I have such a function, 1, 5 is 0, 7. Well, notice that these two matrices, this one and this one, cannot be multiplied. Why? Because the matrix on the left has 1's 2 columns, and the matrix on the right has 1's 2, 3 rows. So I disagree. It's not true. It's an undone operation. Even if you didn't notice it at this moment, outlined it with a scheme, you would still get to this error because there are certain numbers you couldn't help there. So you would come to the conclusion that this operation is not done. And that's exactly the answer in this task. Well, that's it when it comes to basic matrix operations. I encourage you now to do your homework, which is attached to this presentation. This is very important because despite what I said so often that these matrices, especially the basic operations on them, are very simple. Well, they can cause difficulty when it comes to one thing, namely that a lot of calculations need to be performed in it. When there's a lot of calculations, there's a high chance of making a calculation error, something small, like adding minus 4 to 3. Someone might get it to be plus 1, for example, of course done is sure. We say it should be -1, and one such wrong result, such a small calculation, breaks down the result at the end. So to get in the rhythm right from the start and increase your efficiency, it means making fewer mistakes in a word. You need to perform some of these matrices, and that's why I encourage you to do it.
Homework.
Thank you very much.